I'm on page 49. And remember, as statisticians or people that are doing research, the data can be about anything. And I can do the same thing. I can do a frequency chart, I can do a frequency polygon, I can do a histogram. I can do whatever I want with it. Did you see your assignment? If you are not using your school email, you would not have got it. I sent you assignment number 1 on the weekend. And in the textbook, if you have a new textbook, there is a CD inside it, yes? And the data for the baseball stadium and the cost and all that I sent you on the assignment is also in the back of the back of that CD. If you want to use software rather than hard copy, you can just carry that data into Excel or Megastats. Megastats is also on the CD. So maybe sometime this week we'll do Megastats, a quick run over of Megastats so that you can see how it works. The assignment is due on Sunday. Any questions? And we will have covered the last part of it in the next few minutes, mean, median, mode, standard deviation, and then I think everything that was in there you should be able to do. But your choice, if you want to do it with the calculator, that's fine also. All right, so let's do a quick review on page 49. Midland National Bank selected a sample of 40 students checking accounts. Below are the end of month balances. Do I have quantitative or qualitative data?
Which page?
49, and quantitative is always a good guess. And is it discrete or continuous? Continuous. It is money. So it says to start with telling the data into a frequency distribution using $100 as a class interval and 0 as a starting point. Let's put it in the calculator because we are also going to start moving into finding mean and standard deviation with it as well. Okay, I know there's a bunch of data here, like 40. But remember the magic number is 30, and we will get to that very quickly where we consider 30 to be a good sample size. Anything bigger, anything less than that, we use different calculations again. So since before most of the stuff we've done has been the small number, just to let you know, and also the assignment has lots of data in it. You're putting that in by hand. Questions about entering the data? None. Yes? So it's already told us what we should do in our classes, but remember we start all of them the same way. We want to know the min, the max, the range, and n. And in this case we know n, and notice I've used a small n. It's a sample. It is not all the students that they have at this bank. So my first move is going to be to put them in ascending order. And I have put mine in list 5, I think, didn't I? Is the smallest 127? Yeah. And the largest? 968. So what is the range here? It means that we're going to subtract max minus min. So what the range means is that our data covers 941 numbers. See, that's a very large range. Sometimes when we were doing the oil changes, we had a range of about 6. So this is a large range, and n is 40. How many classes are you going to assume or guess? So we would do 2 to the k has to be greater than 40. Right, this is the 2 to the k rule to give us an idea of how many classes that we should have. And how many should we have? 6. 2 to the 6 is 64. We're looking for 6 classes. We might end up with 5, we might end up with 7, but it's telling us when we're working with 40 pieces of data that 6 will be a good number of classes to have. So now we want class size. And so we would have had 941 divided by 6, and that gives us approximately, what, 160? That wiggly sign is an approximate. But we wouldn't count in 160s. We could count in 150, but when it comes to money, it's a lot easier, or anything that's in hundreds, much easier for us to see 100, 200, 300, 400. And that's what they've suggested for you. So on the assignment, I think I asked you exactly the same, to do exactly the same thing as that. And so my class is going to begin with, and I'm going 0 to 100, 100 to 200, and what will be the last class that I will have? And I need to go to 1,000, yes? Okay, is the data mutually exclusive? Meaning each student could only fit into one class here. Mutually exclusive, whatever their bank account was, they were going to fit in to only one place. So if they have $476 in their account, they're into this class and this class only. And it's exhaustive because I don't have anyone that's got less than 0 money and no one that has more than 1,000. So we need to check that. And I noticed on Thursday lots of questions about discrete and continuous. Discrete means I'm counting. The number of students in this class is discrete. Your height is going to be continuous because I can't just go 1, 2, 3, 4, 5 when it comes to measuring your height. So in here, money is continuous as well. If I want, I can go through and count myself, or I can use the calculator. So this time the calculator is going to be much help for us. I'm going to start the x at 0 because that's where my table starts. And I'm going to finish it at 1,000 because that's what, making sure I cover the last student. And here, what will be my class size? This is 100. It's already been decided, 100. And I'll redo it quickly on the calculator and show you 150, because we could have chosen 150 here. So 100. And again, I'm going to leave my x min to be 0. I have to, but my x max I'm going to make 20, because my guess is always half the data. I doubt that half of the students are going to fit into one class, but because I don't know that, I'm just going to make a guess. If my table is too tiny, I'll change y to be something else. Okay, so I'm going to stat plot the first one. I'm going to do a histogram on list 5. Okay, am I moving too fast? Are all of you okay with this? So you see, I could get rid of the 20 and make it, say, 15. Let me do that so the window's a bit bigger. We call this a front-end load, meaning that more students have very few, less money than large amounts. When we start to get up to the 900, 800, 900, and whatever, very few students. When we start to talk about 100 to 500, we have almost all of them. So this would be called a front-end load or a positive skew. Okay, so I'm going to put the frequency in, and my first check will be to trace to be sure that I have them all. And it says that I'm in list, that I'm doing this from plot 1, list 5, that's correct. And my first one is 0 to 100, and I have 9. And then it looks like 777. Go 6. 3 6s. 5 5 2. And what will this total? Does it? 9, 15, 20, 32, 34, 35, 38, 39, 40. Good. You know that's got to be your check, that you have to be sure that you've got the correct number of data in when we start. Questions so far? Is there anyone that can't do this part of the assignment? How did you get it? You have to add these all up. Yeah. No, I got yes from there. You got 10 though, which in that one. Does everybody agree? Did somebody get 10 in the first one? Okay, let go back and have a look. Okay, here, look at, just check yours with mine. Because you made a mistake in row 1, right? In your first, the first one. No, but that's asking for a value of y. I don't know what that's doing. Right? That's something still in here. I don't know. Because usually when it's in stats, it won't do anything but read whatever you like, these exact numbers. It wouldn't do anything else. Any questions? So we could do a cumulative graph. You know how to do that. What would I do if I wanted to pull that off? What would I need to do frequency polygon or a cumulative graph? What am I putting in the calculator for this list? I need a midpoint. Are we okay with this? Because I want to go on to chapter 3, but I want to be sure that this language and everything we've done. Even though there are different chapters, we're still just moving on. So when we gave a report, we might show this histogram. Let me put it back. We would show the histogram and you would label the axes, yes? This would be dollars, this would be frequency, this would be students' accounts. All right, I'm moving on to chapter 3 now. I'm going to leave this up because we're going to use this data to find the information that they've got on chapter 3. So usually that we have more than just a graph to show them. So usually we want to know the mean. That should be a review for you, yes? So we total up all the values that we have and we divide by n. And we have two symbols. If it's the population, then we use this symbol. And especially when we're doing hypothesis testing, we use that symbol or the bar to make sure that you understand whether we're talking about population or sample. For sample, we're going to use this one. And we find it by adding up all the values and dividing by n. But you can guess there must be a button in this calculator for that. You don't want to see me add these up and divide by 40, do you? So let's go to stats. Now we're starting to calculate. So we're choosing calculate, and up until probably the last few weeks of class, we will always have one variable. In this case, our variable is the amount of money in students' bank accounts. One variable. So we're choosing one variable, enter. And now yours might look different because this is the new operating system. If you don't have it, you need to just type in wherever you put your data. So you will have, does everyone have this one? Okay, so you'll have something that looks like, I'm forgetting. And you're, I don't know, it might not even have the bracket, but you're going, where did you put your data? This one?
Yes.
Okay, just type in list 1 and enter. I put mine in list 5. Frequency, if it's not going to ask you, so you don't need to do that. Oh, I just saw it as it went by. Everybody okay with that?
What did you do?
I have the new operating system, so you need to choose one variable. Well, you have the new operating system as well.
This one.
Yeah, pass the next one, because there is nothing special though. Yeah. So, the mean. Do you see the symbol? In this case, it's 315.78. So what we would say on average, these 40 students is 315.78. And that we have a range of $941, so that once you see that, you know that 315 is not a great representative of this crowd without us knowing something else. Do you see? If my range had been 50, then me talking about 315 would be okay, but my range is 900, almost 1,000. So I know that I must have people at 0 and I must have people a lot bigger to end up with a mean of 315. Yeah?
So you want down one near plus 7.8, right?
It says 0.775, right?
Yes.
Okay, but usually if it wasn't money, I would have only gone one significant figure past the answer. So in the data we use 315, right? Like no decimal places. So I would have in other data, I would have made this 0.8. One decimal place past. But because it's money, I put it into cents. Okay, and these other things, the sum of x, that's what this says. The symbol says that the sum of all 40 pieces of data was 12,631. We rarely use that, but somebody could be asking, so it's there. There are other formulas that sometimes you need the sum. We also need the sum of x squared because there's other ways of finding standard deviation. This S of x is standard deviation of a sample. And this one is standard deviation of a population. N is 40, so we know that's correct. Let's scroll down. The minimum is 27. Are we correct?
Yes.
The first quarter, we're not there yet, so we haven't done that. The median is 265.5. And the median means the middle mark. So let's go back and we'll use the data that we have and find it. We've got 40 pieces of data. Where should this middle mark be? So I have 40. So that means that, say this is
22.
So the 40th mark is going to be right between number 20 and number 21. So let's go back and look at our data that's in the list. So I can go down, and you know, they've labeled them. They've told me this is my first term, so I don't need to count. There's number 20. And there's number 21. So I'm looking for a value that falls between 252 and 279. So if you did it by yourself, you would add the two together and divide by 2. I have to tell you that the median and the calculator will not always have been calculated that way. There is a formula for percentile, and it will use that formula rather than this one. Questions about median? This should be review as well, yes? And what's the third M that we do? It's the mode, and the calculator doesn't do that at all for you. You have to do your own counting. So let's go back and see if there is a mode here. Okay, so sometimes the mode makes sense. If I was running a store and the most popular shoe size was 39, I'd want to know that when I'm ordering stock in. For other cases, maybe knowing the most popular isn't that important. And in here, we call this bimodal because we have 2. Sometimes we have none because there's no value repeated. Sometimes we have 3 or 4, and sometimes we have just 1. What we really like, when we're really comfortable, would be that the sample, the median, and the mode was all the same number. And then clearly, whatever someone's asking us, if we give that number, then it represents everything. If it's the middle number, if it's the most popular number, or if it's the average. So when all those things come together, we're quite happy to say that the average amount of money in the bank account is something. But in our case, we don't have that option. You see, they are not all identical. And the word average, for some people, we usually see that as a mean. But in statistics, using one of the 3 M's is fine as an average. So let's talk about them, because soon we're going to talk about outliers. So let's assume that we were finding the average age of this class, the students in this class. And we totaled it up. And let me make a guess. Will it be about 21? Do you think? Okay, now what if you added me in? The average now would be 30 maybe. Yes, do you see? Me alone will carry that average to be what we would say not representative. So it's your choice. Since you must start with all the data and you must explain something you leave out, you could circle my age and say that I'm an outlier, and we have a test to show that I would be, right? And that we've left it off for that reason. There are other ways that we would want to include it. Let's say that we were taking the wages that your star cricket players or football players get. There are some of them that get way more than everyone else, right? The heroes, the stars. If I include the stars, then management would be saying we pay our football players a large amount, right? Because the mean would be moved up because of the stars. The players might leave the stars off and say, look, we only make this amount. Did you see? So the only one of those 3 that's affected by an outlier is the mean. Because the median doesn't care. It's still going to be in the middle whether I have an outrageous number or not. And the mode, it doesn't matter unless I've got a bunch of outliers. All the same won't affect either. So you need to remember that, and that question comes up all sorts of times, and you have to make some sort of decision. So, okay, so we are on page, okay, I've skipped a few now. Median, mode, and I am on page 67. And basically, just because we're talking about the shape that we're going to have, if the mean, median, and mode, like I said, was all in the same place, then we would end up with what we call a symmetric distribution. Everyone has exactly the same spot. in our case, what do we have? Well, it's really the median. It's really the median and the mode. So our median is here at 265, and our mode is over here at 315. This we consider to be positive skewed. And you saw that when we drew the histogram. All the values came at the beginning. If we have it the other way, it's negative skewed. It means that we are at the end loaded and we have more marks at the This would have been the mean then. Let me fix it. We would have had a mean here of this one, and the median would have been out here. This would have been a negative. We'll see this many, many times. I'm just putting it up now so that you can start paying attention to why we would want the mean, median, and mode put together. Okay. We're going to look at the deviations here, standard deviation. I'm going to do one by hand. And the only reason I'm doing that is so that you will be in awe of your calculator. Please keep this data on your calculator, though, because I want to go back and finish. I just don't want to do 40 values for standard deviation. So right now, you can talk about your data. You can say that it's continuous or discrete. You can give the range. You can give the number, n, and now you could add mean, median, and mode to it. So we want to add standard deviation. So let me see some where I'm not doing. Oh, okay, on page 75 because I've only got a few points. And this is weights of containers being shipped to Ireland in thousands of pounds. Quantitative or qualitative? Quantitative. Discrete or continuous? Continuous, it's weight, yes? And I'm going to put them in order. Is it 7? No, 8. What am I missing? 110. Okay, so I put them in order. You could have easily put them in the calculator and had it do them for you. Well, why don't I wait while you do that? So what I want to do is the standard deviation says how far away from mean is each one of these points. So my first move is to find the mean. So has somebody put it in the calculator? Anyone? I'll do it. Okay, I have not 15 pieces of data. What happened here? Okay, no one has the mean yet? So in this case, I've only got a range of 22. Nobody has the mean? I think you're just not telling me. Stats. Calculate. List 4 from E. Okay, and for sure you will know that something's wrong if you end up with a mean that seems to be outside of your range. My range is between 90 and 112. And it's saying that the mean for this set of data is 103. Anyone not being able to find the mean? Should I be waiting?
7.
X bar, yes. Okay, so what the standard deviation is saying is, well, let's find just a deviation to begin with.
What's the range 22?
Where did I get 22?
Yeah.
I subtracted. Did I not do that right? Min's the max. So what I want to know is how far away are all of these points from my average of 103. If all of the values are very close together, I'm going to get hardly any deviation. That's good. Then whatever number I use really represents my data. If it's a long distance away, I need to know that. For example, if there is a football player that's a bit of a wild man, so some games he makes 3 or 4 scores, and other games he does nothing. So he's all over the map. Where I have a consistently good player that scores 1 goal every game. Their averages will be the same, but their standard deviation will tell me one of them is all over the map, one of them is very consistent. So here, my first move, when I want to see how far away they are, is I'm going to subtract X bar from each one of my values. No, 13. Now, if I'm correct, what should this total be this time? I'm trying to find out how far away each one of my values are. This should total 0, because I should have as many on the negative side as I do on the positive side. So if I add this up, I have minus 21, and if I add this side, 16, 17, 18, 19, 20, 21. This should be 0. That makes sense though, right? I have a value, I've got all the beginning points that are lower than it, and all the bigger points that are larger than it. From now on, anything I do is just formula. The reasoning behind it in stats, what happens is that they would have found the standard deviation and they would have worked the formula out to fit it. So the reason that I don't care if you remember the formula is because after this first move, it's just a way of getting a number. So the second part of it, the story goes that we don't want to have negative numbers, so we square them, but there are other ways of getting rid of negative numbers. Okay, so 169, 64, 0, 1, 4, 4, 49, and 81. And so the standard deviation is equal to the sum of x minus x bar, in this case divided by n minus 1, and let me make this variant so I can do it first. So what do I get when I add this total? $368, I'm guessing. So the variance in this case would be 368, and because it's a sample, I'm going to divide by n minus 1. So that is 7. approximately. So we rarely use the variance, but it turns up in some formulas. And so the standard deviation is the root. And what do I get when I take the square root of this? What is the root of 52.6? $7.2? $7.3? So you see, there's no reason to do it by hand because I have the standard deviation here, 7.3. It's a sample, so I use this one. If it's a population, I use this one. It's a population, I divide by n. You are not going to do this by hand, ever, ever, ever. What I want you to know, though, is you would say, and let's put all of this into words, because descriptive statistics are just that. They're describing the data we have. So here we would say, on average, students, and I don't know where that, no, this wasn't students, this was weights of bags to Ireland is, and what did we say it was? 103,000 pounds.
Sarah, just hang on for 1 second. I don't think anyone's in the same place because did anyone see a mistake in 368?
What? Where was the mistake?
368 wasn't the right total.
What was it?
375. Don't you know if you find 3 mistakes, you get to go?
And you got the calculators there. I'm doing this in my head.
I can show it to you. You have a calculator. That should have been 375.
And 25.3 for...
It was just adding the total. You could have all checked that on your calculator.
Yes, because it... Well, I could have done it, couldn't I?
No.
No, it's not. It already squared it. And what does this turn out to be now? Well, it's still 7.3. So you would use the sentence you would write, or you would talk about, is we would say that the average weight of containers sent to Ireland is 103,000 pounds, and then I use this: give or take 7 pounds, 7,000 pounds. And the give or take means that I know that by basically nature that 68% of the population will fall between one standard deviation. Let me draw that because that's difficult to see. So when we were doing the graphical section, we left out the normal curve. I told you we would come to it soon. This is it. Something else now. I've written this away. This is called the normal curve. And in most situations, if you went out and measured leaves or caught a dozen fish and measured them or randomly chose some people and weighed them, it almost always turns into a normal curve. Meaning, in the center here, I will have my mean, and then I'm going to put standard deviations on both sides. There will be less and less people at this extreme and less people at this extreme. So this will be 1 standard deviation. This will be 2. And this is 3. In most cases, in most populations, by the time you get to 3 standard deviations, you've looked after everybody. So the empirical rule that is used is that 1 standard deviation each side of the mean is 68%. That's just a given. So in this case, if I go back and look, and I erased it. If I go back and look, I will find that 1 standard deviation away from here is going to be 103. I'm going to add a 7 here, so that's 110. And I'm going to take a 7 off here, which will leave it to be 96. Okay? Can you count the number of packages that weighed between 96 and 110? 1, 2, 3, 4, 5. And what is 5 out of 8? I'll do it. 62%? Okay, I know you're lost. You don't have a clue what I'm saying, do you? Let me go back.
Yeah, that 75 was wrong too.
Is it?
It was 72. Apparently neither of us can.
Oh, this is wrong?
Anyway, it doesn't affect the
It doesn't matter.
But it should be 372.
Okay.
Just so you have it in your notes.
Okay, let's go back, because this whole idea of the normal curve is what we do for like 2 months. All hypothesis testing, any type of test is done with the normal curve. So it's called normal is because that's what we expect. So again, if we were to gather birds or measure leaves on a tree or anything, everything fits into this normal curve. And the empirical rule is that 1 standard deviation each side of the mean looks after 68% of the population. And I just showed you here, the mean was 103 for our bags going to Ireland. And 1 standard deviation on each side became 96 to 110. Yes? If you count the data that falls between there are 5 pieces of data that are bigger than 96 and smaller than 110. Yes? Count. You're looking like I'm talking some foreign language. Am I? Let me put the... what do I do with it? I shouldn't have erased it. Thank you. Okay, let me go back. Here it is in order. They said the mean was 103. 1 standard deviation means I'm going to add a 7 and subtract a 7. That makes it approximately 96. So I'm not counting this one. And if I add down to 110. So these are the values that fall between standard deviation here and the standard deviation there. Now the rule of thumb says that 68% of my data will fall there. What percent of my data fell here? 1, 2, 3, 4. Well, this one 50%. I included that one. That's fine. 5 out of 8. Yes, 68% or 62%. And in everything you could think of measuring, it will be the same. That's just how life has unfolded for us. So when I tell you that the average of the bags is 103,000, that tells you one thing, but there could be bags that are very tiny, and there could be bags that are very large. But you know that's not so, because these bags are only varying by 7,000 pounds. So 68 of them, now let's put the real values in for this one then. So this is 103, so 110 and 96. 2 standard deviations away is going to be 117 and 89, and I've already used up all my data. Oh no, I have one left. No, gone. So this first part is 68%. By the time I get to 2 standard deviations away, I'm now at 95% of my data. And am I? Well, I'm at 100 actually. At this one, I'm already at 100. But it's because I only have so few pieces to start with. And the last one, if I take 7 off here and add 7 onto here, this last one is 99.7%. So, if somebody said to you that they had shipped a bag from Ireland and it weighed 150,000 pounds, you should be saying, I think not. Do you see? That would be outrageous, because here at 124, we basically have all the bags. It doesn't mean there couldn't be somebody outrageous. And like I said, if we put my age back into this, the standard deviation would be there, and I would be one of the freaks. I'd be an outlier, a freak of nature, fitting outside of 99.7% of the population. Okay? So if you haven't got it this time, we'll do enough of them that you will see how it goes. So let's go back to the info you have on your calculator for the amount of money the students have. So we're already going to say that we have 40 students. And what was the min and max of the amount of money that they have? How much? 25?
27.
And?
968.
968. We're going to give the range as well, because that helps us get an idea. I mean, if the range is only 50, we know that almost everybody has the same amount of money. Our range is 900 and something, yes? So we have 40 pieces of data that ranges over 941 pieces of values. So we know that the standard deviation is going to be pretty big in this one. If all the money was within, say, $100, we'd have a very tiny standard deviation. So what else do we know here? We know that what the median was. What was the median here? What was it? And the mode, we had 2 of them, yes? 234? Okay, so we're going to add to this now, and we're going to look at the standard deviation. And so, let's see, stats, calculate, one variable, and remember, the only variable we're talking about now is students' bank accounts. So, for me, it's in list 5. So my mean is 300 and, I forgot to put that on, 315. And if we're talking money, I probably would have written at 0.78. And the standard deviation, remember this is a sample. So I'm using SX, not the sleeping peak, 243.74. So the word you would use is that on average the students have $315 in their bank account, give or take $243. So drawing it as a mean, drawing the mean in here, I've got 315. I'm just going to make it 316 so you can just get an idea here. 316, and I'm going to make this 244. So 244 here. I've been doing so badly adding, so So I got rid of all of them in here. Questions? All right. So I've moved on to, well, there's examples of calculations in here if you have that incredible need to do one of them by hand. If not, let me move on. The empirical rule is drawn to you on page 83. And now I'm back to I want to redo this in group data. Does somebody still have it? Can I borrow your notes? I want to show you that if you start with raw data, this is the information we got. I'm going to redo it with group data and see just how far off we are, because a lot of times we start with a group, right? So I just need to put it back up here.